Hi everyone, GWeb is a tool developed by National Instruments and it is part of a larger ecosystem that includes core products like LabVIEW, NI Web Server, web services, and many other tools developed by NI, such as VDM, Video Development Module, TestStand, Database Connectivity Toolkit, Real-Time Software, many other software tools, as well as hardware, peripheral devices, and of course the drivers for them. This topic is so vast that even just listing all the directions and capabilities would take hours. But overall, if we talk about the programming market, there is probably no other tool that is as connected, structured, and convenient as NI products. Of course, you usually hear about completely different things. You constantly hear about Python, JavaScript, C++, PHP, and hundreds of other programming languages, and you might try to compare them or look for statistics. Where is LabVIEW? What place does it hold in the rankings? You won't find such statistics, and if you do, most likely those people who compiled them don't really understand what they're doing. You can compare sweet and purple. GWeb and LabVIEW by themselves are a superstructure, a shell around knowledge and capabilities that humanity has created. It's like artificial intelligence. By itself, this term has no meaning without the knowledge that humanity has accumulated over thousands of years. Why am I saying this? There are a lot of comments with roughly the same question. Who needs this and what is it for? Of course, if you were taught classical text-based programming, this question makes sense. Because really, if you spent your whole life studying, for example, cell structure and biochemical processes, it would be unclear how that knowledge helps you cook a dish or fix a refrigerator. Programming in LabVIEW is not the same thing as programming in Python. For example, what you would need in Python to build a more or less advanced application in terms of knowledge and time is completely incomparable to developing the same application in LabVIEW. In LabVIEW, this can be just a couple of functions which already exist in libraries, and you only need to add a bit of logic, and that's it. The fundamental difference between a developer working in LabVIEW and, say, Python is that LabVIEW makes no sense if you do not understand the essence of problem or task you're solving. In Python, you can calmly work on a piece of code without necessarily understanding the whole problem. The same applies to JavaScript. If someone tells you to write a function to read and write a file, for example, you don't need any knowledge about the SpaceX spacecraft, where this function will later be used as a small part of a larger architecture. In LabVIEW, it's completely different. If you don't understand the essence of the process, if you're not the creator of that process, then you don't need this tool. So, to summarize, our channel is for developers, DevOps engineers, not for programmers. And even though the job title here in Silicon Valley especially might be software engineer, that doesn't necessarily mean that this role involves performing engineering functions. How do you tell the difference? It's simple. If you're solving isolated parts of a task, you are a programmer. But if while solving a problem, you see the whole picture and make decisions based on an understanding of what you ultimately want to achieve, then you are a developer, an engineer. For example, if you work in the video game industry, there are many people work on a single project. Someone programs the characters, someone works on the landscape or the background, someone does mapping. In short, everyone has their own task, and everyone more or less understands what kind of game will come out at the end, and some of them even play it themselves. But only one person in the development team is able to truly comprehend the whole picture and build a development strategy. This is the person who, like building with blocks, takes the results of the individual programmer's work and creates the actual computer game. And for this person, each developer is simply a creator of a function that gets integrated into the program. The same can be said about a developer working in the LabVIEW development environment, only in this case, programmers who create functions are no longer required because functions already exist. You just need to know how to find them and how to correctly integrate them into the architecture of the program. And today we'll look at the difference between a programmer and the software architect, the developer. Right now, I will create a simple game from start to finish. And here, perhaps the most important thing will not be to create the game itself or to publish it for millions of users, but something even more important, to understand why I am creating this game, what benefit it will bring to others and to me personally. And here you have to agree with me, I'm fundamentally different from a typical programmer. For most programmers or even software engineers, this kind of philosophy is simply outside their field of view. All right, let's begin. Today I'll show you how I created the game Tetris and at the same time a shooter game that I call Bubble Shooter Game. Of course, I didn't invent anything. As you know, engineers are not supposed to invent things. They are supposed to apply what has already been invented. But how to apply it and which techniques to use, that is already engineering work. Of course, I didn't invent Tetris. This game, Tetris, was created in 1985 by Alex Pajitnov, a Soviet engineer and programmer who worked at the Computer Center of the Academy of Sciences of the USSR in Moscow. There are many variations of Tetris. As I already said, as an engineer, what interests me here is the application, not the essence itself. So I approach the problem using the engineering mindset. I simply look at what reliable and optimal solutions already exist on the market, and for my search, I use the most convenient resources. And of course, in my case, ChatGPT will help me with this. I will simply order Tetris as a function for my program and then adjust the design and functional properties along the way. All right, let's create a prompt and move forward. I'm intentionally not going to show you my prompt in ChatGPT so I don't kill your creative spark. Even if you simply write ChatGPT, give me a nice version of Tetris with all the game arguments and speed control in JavaScript, you will get that function in seconds. Then, of course, you'll need to fix bugs and adjust the design. That's a matter of personal taste. For now, ChatGPT is not perfect at this, so you will always have something to work on. So let's say you end up with something like this. Here my function is called add Tetris, and these are the arguments: container element, start button, left button, rotate button, right button, down button, stop button, color U32, and background image URL. Let's see. Okay. In this case, I only skimmed through the code visually. I didn't dive into the programming flow. What matters to me is that this function works fast, and doesn't consume many resources. What else is important? Probably nothing more. Oh yes, and one more thing, I don't need to deal with any kind of proprietary barriers. It's considered that I created this program, and therefore all the rights belong to me. So now all that's left is to integrate this function into my JavaScript library so that I can get it in a form where I can place it on the diagram. Let's create the function in our JavaScript library. I will also add parameters, arguments. Okay, so I added this same function, and let's see its icon on the diagram. If we go to project items, software, web app, library, here we see our function icon. And we actually can make it a different color through the JavaScript library. We just go to click on the function, edit icon, and change background color, let's say to purple, for example. Click done and go back to diagram, and here on the inputs, where the inputs of the functions are, we see all our arguments that I just created. Yes, and on the right here as well in the menu. So obviously this is a fictional function. It doesn't exist in reality, and there is not a single line about this function in my code. So I delete it. I don't need it. I just showed you how a function icon appears on our diagram, and I will need to delete it from here as well, from the library. Okay. And now on the diagram, let's find these three functions: add PayPal button, add Tetris, and add logo animation. Let's see. Here it is: add logo animation, add PayPal button, and add Tetris. These are the three Tetris functions that are embedded in our Java code. So we've seen where this icon came from. As you can see, as an engineer, I'm no longer particularly concerned with the function itself. I created it once and forgot about it. Now, what matters to me is the program architecture, the logic, and the design. Let's say I want to sell this program and I've added some usage limitations, and I offer the user, if they like the program, to go to the payment page. Let's go to the front panel, run the program. And here we have the button purchase template. And we see here that we have a PayPal button on this purchase template page. There is, in a way, a philosophy behind creating any application, the final goal. What do I ultimately want? To make money, for example, or for some device to perform a certain task, or say for a rocket to fly into space. So in this case, let's assume my final goal is to make money. Or maybe my final goal is to get humanity hooked on my program and make it so that all factories and ships stop working and everyone just plays my game. And then peace and harmony will come to Earth. Everyone will just play and not think about wars. Obviously, I'm dreaming now. My point is that we cannot always clearly understand what the ultimate goal behind certain things is. That final goal is embedded by the creator of the program or the process. And this is exactly where you can clearly see the difference, where the programmer ends, where the developer, the engineer, the architect begins. All right, let's look at the logic. Here we have the PayPal payment button. It works only in the browser. This is what this button looks like on our website. If we go to our website, laplanda.com, we can find our template here. And if we click on it, we go to the browser. Yes, here on the page, we see the PayPal button, and as well as in the browser, we can see that we have the purchase template button, and here's the PayPal button. Here I also have a back to home button. Let's stop the program and see this button on the diagram. Find it on the diagram, back to home. And we see that this button controls the case where page redirection happens. In my case, these are tabs. There is also a second button that controls the same case. Let's see what button that is. Find on front panel. Here it is. This button is placed on the instruction page. Although honestly, Tetris probably doesn't really need instructions. Let's see what I have also in the timeout event case. We see that in the timeout, I have the function add Tetris. And here 2 loops are running, 2 cycles. That is, the event case itself runs at a speed of 50 milliseconds. The JavaScript code itself is running in real time. Our function is ready for execution and for state changes when any of the control buttons are pressed. Let's press on Tetris Start, and we see it on the front panel. The game itself runs directly from this tab. About the buttons. I added the buttons here myself. I'll show you what they look like. If we go to the to our project on the computer, I have a folder here with all these buttons. I found them online and I like them, but you can use absolutely any ones you want. Of course, this image itself is not a button. It's just the background of a button. So it's clear that the background can be anything. And that means the button itself can look however you want. Well, that's probably all there is to say here. Yes, about the background pictures. I built the logic here so that when I press the button called, let's find it on diagram, the button called Tetris image change, I control the index array through a shift register. An array is a collection of my images. Here are all the links to my images. These are all my URLs. And they are located in a folder on the hosting server. And let me show you something. Let me show you the last link. And this is a little life hack for you. If you are too lazy to look for a decent image without licensing issues that you need to place somewhere on a web host so that there is always a new image, you can use this website. This image changes here every 30 seconds. So by using this URL, you can connect it to your HTML window and you won't need to think every time about which new picture to put there. Yes, a couple of words regarding the score. After all, we play Tetris for the result. We get that sense of excitement and maybe even compete with someone. For this, I created 2 windows on the front panel. You see them here. And the window on the right shows the number of lines I managed to clear, and the window on the left shows the level I managed to reach. By the way, you can see that these windows are color styled. In one of the episodes, I did this using CSS code that I placed directly into the HTML code here. But this time I used a different approach. I added a CSS file to the project. But I won't stop on details regarding this because you already know all of this. If you don't, check out the previous episodes on our channel. Now, about the score logic itself. Let's find on the diagram here. So JavaScript gives me the number of cleared lines. Here I made a simple transformation of this value. I divided by 10 and add 0.5. And since this represents my game level, it will always show an integer, the nearest whole number to that calculated value. So for example, if I have 100 cleared lines, I divide this number by 10, I get 10, then I add 0.5, and the result is that my level becomes 11. Obviously, when you design your own game, you can play around with the level logic however you like. That's basically it. Let's see how this game works in the program and in the browser. I run the program, click enter, let's change the background. You see this last one image that is from the link that I showed you from the website that you can use. I will change the background to something different. Okay, so this button works. Let's test the start button and the left button, the right button, the drop button, and let's test this button here to switch the position. Here it also works, and we press stop. I also test the button exit, and here we are on the page of the instruction, and here we click back to home, purchase template, back to home. Everything works. Now let's see how it works in the browser. Okay, here I already have it open. So I press enter. We click background image change. Again, go to the last one and we see a different image. As I told you, it changes every 30 seconds. Let me go back to the plain background. Let's, for example, this one. And I play. Let's play. I start the button and then go left, go right, drop this one as well. And here we switch the position and stop the game. And if we want to exit, we click on exit and back to home. Everything works. Let's check how the payment button works. Okay, I already showed you this actually, but still. Yes, and one more thing. I also made the keyboard work when I'm on a computer. And if I'm on a phone, I added an option in my JavaScript code that I call prevent double click zooming. I named it that myself. I don't know what the correct term is, but you get the idea. This is especially important on the iPhone because when you tap something on the screen, it always tries to zoom in. And obviously, playing like this is impossible. The screen will keep jumping all the time. So it makes sense to disable this iPhone feature. This little life hack is embedded in my JavaScript code. I'll leave the link to the project in the description. If you're interested, you can take a look. Alright, now let's take a look at another game. I also made it pretty quickly just to demonstrate the principle. Let's open the project. Here it is, bubble shooter. All right, here's how it works. I run the program, click play. I didn't change the buttons here, although it would have been logical to change them according to the design. So right now we are focusing on the architecture. The design is secondary. There is also an instruction button here, providing information about the game. And if I click continue and go back to the first page, home page, there is also a button here to change the background. Let's see. Yes, and we have all the backgrounds here from the previous game as well. And here are the game buttons. The game itself is quite primitive. The goal is to hit as many balls as possible. There are only 3 control buttons: a left, right, and shoot. And let's start the program. Let's test the buttons. Oh no. Clearly I overdid with the speed here. I should have made it slower, but if you like the game, download the project and slow it down yourself. Oh, and I also added a pause button here. Let me click play again, and then I click pause. And here's a slightly different logic. Let's see it on the diagram. I will open timeout case. Here we see that the JavaScript function is located in the same timeout case, but I've placed each button in its own separate case. Here's the case for Tetris start, for button left, for button rotate, Tetris right, shoot, and stop. All right. And these buttons control the state of the JavaScript using a shift register. And another thing I added here is automatic control of the ball's movement speed. Here on the, I need to stop the program. Here on our function at space shooter, I have speed set and base enemy speed, these arguments. And I call the bubbles enemies that needed to be popped. All right, I think it's all clear how it works. I've included links to the projects in the description. You can download them and see how they all work by yourself. By the way, feel free to suggest your own versions. I'll post the most interesting ones on our website, laplanda.com. Let's see how this game works in a browser. And we can find it here on our laplanda.com website /dev-eng. Here we go, bubble shooter game, click on it, and here's our game in the browser. It doesn't have a frame. I tried it this way, maybe it looks better, but that's a matter of taste. I have just one play button here, so I press it. We check how the instructions work by clicking the exit button. Then let's click continue and play. Let's test the background change button. We see that background changes, everything is good. Let's check all other buttons, how we start the game. Let's play. Okay, let's click pause. Okay, it works. And shoot, the button shoot works, and the button left and right also work. It's just that I really overdid it with the speed here. Yeah, it's too fast. If anyone wants to work on it and improve it, feel free. The source code is in the description. How to build, compile into a static website, I explained in previous episodes. How to upload it to hosting via FileZilla, I also covered in previous episodes. You can find them all on our channel. Obviously, today I showed how to create very simple games. For more advanced games, you'll need a bit more time than half an hour. The goal today was to show the principle and the philosophy. That's exactly what we talk about on my channel, and there is more to come. That's all I've got for today. Thank you for joining La Planta Tech. If you have any questions, please leave them in the comments. If you learned something new today, give this video a like and subscribe to learn more from upcoming episodes.